Unlike nitrogen, sulfur their symptoms appear first at young leaf. Okay. Um, Sebab apa dekat young leaf, even though sulfur dia adalah mobile, because sulfur kita tahu 90% of sulfur in plant tissues exists in amino acids. Okay, so this amino acid is required for to produce enzymes. So this enzyme involved in synthesis of chlorophyll. So indirectly, lower concentrations of sulfur will cause lower concentrations of uh, certain amino acids. Okay, dia ada dua amino acid yang mengandungi sulfur. So bila this amino acid lower, dia tak boleh menghasilkan enzymes yang involved in synthesis of chlorophylls. Okay. Apart from chlorosis, lower concentrations of sulfur also will cause reduce in plant growth, and also the maturity will be delayed. Okay, so tak macam nitrogen. Kalau nitrogen deficiency, the maturity will become faster. Okay, sebagai contoh, kalau awak tanam pokok jagung and then you supply with lower amount of nitrogen, the times taken for this plant to produce yields will faster. Okay, sebab apa? Dia punya concentration nitrogen tu rendah. So dia, kalau untuk keadaan biasa, dia punya nitrogen tak cukup, so apa yang berlaku, the senescence process of growth process will become faster. But difference from nitrogen, when plants suffer from sulfur deficiency, maturity will become delayed. Okay, so this is a picture. Plants suffer from sulfur deficiency. Kalau awak tengok dekat sini, ini adalah pokok jagung. So kalau kita tengok, dia ada berlaku juga chlorosis. Okay, tapi berbeza dengan nitrogen ataupun magnesium. The chlorosis symptoms will appear at newly formed organs ataupun daun-daun yang masih muda ni. Okay. Apa beza dengan deficient apart from kalau kita nak tengok perbezaan deficiency magnesium dengan sulfur ni, magnesium dia punya deficiency dekat intervenous. Okay, tapi kalau sulfur ni dia punya deficiency sekata. Okay, macam nitrogen juga dia punya deficiency sekata. Okay, ini adalah pokok legumes. Okay, yang sebelah kiri ni ada legumes. So these legumes suffer from sulfur deficiency. So there are two symptoms that can be observed in this plant. Okay, apart from chlorosis, their growth also significantly lower compared to normal legumes. Okay. So any questions? Ada soalan tak? Kenapa awak senyap je semua?
Ada.
No questions? Okay, if there are no questions, can we take a break? Kita start semula pukul 11. Boleh tak? Okay. So kita take a break about 10 minutes and then we will continue with our next lecture. Okay, at 11 o'clock. Okay. See you at 11. Okay, hi, Assalamualaikum. So, can we continue with our new lecture? Boleh ke?
Okay, doktor.
So, tadi kita baru habis topik untuk minggu ketiga, which we have already covered primary macronutrients and also secondary macronutrients. And today we will cover topics about topics about micronutrients, nutrients that required by plant in very low amount. Okay, even though their concentrations in plant tissue usually in 0.01%, it essentiality is comparable to macronutrients. Without these elements, also plants will um, show a specific nutrients deficiency. Okay, if you still remember, ada berapa micronutrients? So elements that being classified into micronutrients are ions, chlorides, molybdenums, manganese, zinc, copper, and nickels. Okay. So to discuss about micronutrients, today we will discuss about ions, calciums, and also molybdenums. And minggu depan kita akan bincangkan elements-elements dalam groups micronutrients. To discuss about micronutrients, I will divide topics into two different topics, which are micronutrients for plants, okay, the functions of micronutrients in plants, uh, and also deficiency. Okay, so let us continue with our first topic, micronutrients for plants. So what is micro? So from its names, micro means small, definite. Micro is nutrients, essential nutrients that required by plant in very small amount. How small it is required by plants? Usually, if we do chemical analysis, we will find that the concentrations or the percentage of this element in plant tissue is lower than 0.01%. Micronutrients required by plant also called trace elements. Okay, apart from being called with micronutrients, it also called trace element. Um, there are five elements which are ions, manganese, copper, nickel, and zincs behave like cations. Okay, what means behave like cations? It is available forms for nutrients, plant nutrients uptake is cations. Okay, positive ions. Uh, Whereas on the other hand, borons, molybdenums, and calciums is required by plant in a form of an ions, okay, or a negative charge ion. So it is found in plant tissue less than 0.01% and excessive of essentials micronutrients can cause toxicity. Okay, so this is uh, uh, symptoms sometimes been confused with deficiency symptoms and toxicity symptoms because we rarely observe uh, toxicity of essentials macronutrients in plants, okay, except if you supply a very high dose of fertilizer, it can cause toxicity to plants. But for micronutrients, apart from biasanya kalau micronutrients kita jarang jumpa deficiency symptoms kecuali dekat marginal soils or soils yang bermasalah seperti acid sulfate soil, porous soil, sandy soil. Tapi biasanya kalau in normal conditions kita akan biasa lebih selalu jumpa toxic effect of micronutrients, okay, compared to its deficiency effects. Sebab apa? Uh, sebab apa kita akan jumpa toxicity symptoms of micronutrients? Because micronutrients required by plants in very small amounts. Usually there is no issue about micronutrient in soil. Plant can get micronutrients abundantly, okay, from soil. So kalau kita macam uh, apply fertilizer indiscriminately ataupun tidak melalui aturan yang betul, we will observe toxicity of micronutrients. Organic matter is an important source of micronutrients, okay, because we know that in organic matter contains different kind of essential elements required by plants, okay. So decompositions of organic matter also is crucial for the continuity of element in soils, okay, because the elements need to be converted, okay, from organic into inorganic so that it continuity cycle in our nature can be boleh terjamin, okay. So this is elements that being grouped or classified as micronutrients by plant in form of uptakes and its sources in soils, okay. So elements that being classified as micronutrients ada berapa? 1, 2, 3, 4, 5, 6, 7, 8. Okay, there are 8 elements classified as micronutrients. They are irons, calciums, manganese, zinc, boron, copper, molybdenums, and the last one is nickels. Ions can be uptake by plant in a form of um, ferric, Fe3 plus or ferrous, but usually plant will uptake iron in F2 plus. But the available forms of ions also can be in ferric, Fe3 plus. Nanti kita akan tengok plant have a certain mechanisms to turn from ferric to ferrous ions. So ions, the majority of ion uptake by plant is come from mineral sources. Okay, chlorines, the major sources is from precipitations of salt. Okay, so we know that in salt it contains sodiums and also uh, chloride. Okay, sodium chloride. So the precipitations of salt will produce uh, chloride ions. Manganese, there are two different chemical form that can be uptake by plants, either in manganite 2 plus or manganite 4 plus ions. Boron usually be uptake by plant in boric acids. Okay, so boric acid when it dissolve in solutions, it can be H3BO3, H3BO3 2 plus 2 minus. Okay, there are different uh, anions of boric that can be exist in soil, but biasanya di dalam bentuk boric acids. Okay, so all these ion can dissolve in soil solutions and produce boric acids. Copper are available for plant uptake in cupric ions, molybdenum in molybdite ions, and nickel in nickel ions. So basically, all these elements are came from mineral, soil mineral. Okay, so these are the factors that can affect the availability of micronutrients in soils. Um, Actually, all these factors can affect not only micronutrients, but it also can affect all essential elements in soils. Okay, for example, total contents of element in soils will determine its availability for plant uptakes. Of course, if the amount of essential elements that dissolve in solutions is very lower, so the availability for plant uptakes will becomes lower lah kan. Okay. Soil texture also can become main factor for nutrients availability in soils. Okay, soils uh, usually contains clay. Apa ya? Saya lupa lah, ada 3 kan elements dalam soil structure. Apa ya? Clay, sands dengan lagi satu apa?
Seal.
Okay, ada seals. Okay, so seals ni dia punya particles paling kecil kan. Sands dia punya particle biasanya paling besar. Okay. So the ratio of seal, clay and sands will determines uh, the availability of elements in soil. So if soil contains high concentrations or high amount of sands, usually this kind of soil will contains low elements or essential elements required by plants. Why? Because like I mentioned earlier, sandy soil will have a very low water holding capacity. So in order for essential elements to become available for plant nutrient uptake, it must be dissolved in soil solutions. Okay. Apart from that, um, apa soils apa sandy soil also usually contains lower amount of organic materials. Okay, if it contains high organic materials also, um, biasanya macam mana saya, kalau kita ada macam sandy soils, okay, macam pre soil ataupun tanah kawasan berpasir, we can increase its fertility by adding organic materials. Okay, because organic materials will serve or will functions like a sponge. It will absorb nutrients, or it will absorb soil. It will absorb water. Okay, dia macam sponge, dia akan absorb water. So it will retains water in soil lebih lama. Okay, dalam masa yang sama, bila organic matter tu dia absorb water, it will retain also elements that dissolve in water. Okay, so organic matter contents or high organic matter contents will usually contains high amount of nutrients. Why? Because this organic matter, dia ada beberapa sebab. Okay, so biasanya kalau soil contains high organic matter, the nutrients in that soil usually higher. Okay, sebab apa? First, it cation capacity, CEC, cation exchange capacity, biasanya tinggi. Sebab apa tinggi? Because this organic material contain charge. Okay, so it can retain the charge elements in soils. Okay, so biasanya kita tahu elemen-elemen essential for plant nutrition, dia punya availability forms adalah dalam bentuk ions. Okay, so ions ni dia boleh loosely bind with organic matter, so it will be retained in soil lebih lama. So apart from that, organic materials can absorb water, macam yang saya cakap tadi. It can serve or functions like a sponge. When it can retain water in soil, the element can dissolve in soil solutions. Hence, eventually it can be used as plant for plant nutrition, plant nutrients. Itu yang kedua. Yang ketiga, organic materials adalah derived from plant or animal residue. These organic materials, a certain part of organic material will actively decompose by uh, uh, soil microorganisms. Okay, so the decompositions of organic material will transform the organic elements into inorganic elements. So these inorganic elements can be used as a plant nutrition also. Soil pH also can determines the availability of nutrients in soils. Usually, elements are available in slightly acidic to normal pH, okay, 5.5 to 7.5. So we call this range of pH is optimal pH for nutrients availability. Okay, so in very acidic soil, biasanya cation, okay, elemen-elements yang wujud dalam positive ions will tend to leach. Okay, sebab apa? In very acidic soil, the concentrations of hydrogen ion is higher. Okay, so this hydrogen ion will replace the cation that initially bind to CEC. Okay, so that um, these elements will dissolve in soil solutions. Okay, tapi disadvantage when it dissolve terlalu banyak, dia mudah leach. Okay, in high pH, the anions become uh, unavailable. Sebab apa? In high pH, apa yang terjadi? OH terlampau banyak. Okay, so OH molecules ni dia akan bind with positive ion in organic materials ataupun dekat soil particles. Okay, so anions ni dia dissolve dalam soil solutions, tapi dia juga senang undergo leaching, okay, in alkaline conditions. Okay, soil aerations also can contribute to availability of essential element in soils. How? Because in aerated soil, the microorganisms populations usually higher. Okay? When the soil microorganisms higher, the soil microorganisms can do their functions in soil. What the functions of soil microorganisms? Soil microorganisms largely involved in decomposition process. Okay, the transforming organic elements into inorganic elements. Apart from that, uh, soil microorganisms also can contribute to the nutrient cycles. Some of soil microorganisms, they can secrete organic acids. So this organic acid will involve in weathering process. So it will transform elements that initially bind tightly with uh, parent materials in rock to dissolve in salt solutions. Okay, nutrients interactions also will affect the availability of certain nutrients. Okay, for example, if concentrations of aluminiums, ions, or manganese are very high, it will disturb the uptakes of phosphorus, because phosphorus will tend to bind with this kind of elements. Apart from that, there are certain protein carrier that are not specific. For example, potassiums. Potassium's protein channels is not very specific. So when calcium's concentrations in soil is very high, it will disturb the uptake of potassiums, because calciums and potassiums, it can pass through or uptake by plant tissue through non-specific protein channels. Okay, so bila dua-dua ion ni terlampau banyak, dia akan mengganggu proses uh, absorptions both elements. Okay, so this is how pH can affect the nutrients availability in soils, okay, especially micronutrients. So from this graph, we can clearly observe the concentrations of boron, copper, manganese, zinc, and ions decrease with the decreasing of soil pH, except for molybdenums. Okay, so molybdenum availability increase with the decreasing of uh, soil pH. Sorry, uh, molybdenum availability are increased with the increasing of soil pH. Okay, so kenapa kebanyakan elements? Okay, for example, kalau awak tengok boron, copper, manganese, zinc, and ions, punya availability in soil decrease with increasing of soil pH. Okay. So kebanyakan ion ini, especially copper, manganese, zinc, and ions are available in soil solutions in the form of apa? In the form of cation, positive ion. Okay. So bila dalam keadaan very high pH, okay, OH ion dia tinggi. So OH ion boleh react with this ion and form the hydroxide ion of this mineral. Okay, for example, it can react with OH to form ferrous oxide, manganese oxide, zinc oxide, and copper oxide. Okay, so when it bind with this oxide molecules, it will become unavailable for plant uptakes. Kalau dalam keadaan positif, kalau dalam keadaan acidic, copper, manganese, zinc ni dia lebih available. Sebab apa? Sebab like I said earlier, in high pH or in low, very low pH or in acidic in acidic conditions, the concentrations of hydrogen ion is increased. So the hydrogen ion will replace the binding site of Fe, zinc, Mn, and Cu in CEC. Okay, so these elements will dissolve in soil solutions and become available for plant nutrient uptakes. Okay, so any questions? Ada sebarang pertanyaan? Okay tak?
Doktor boleh ulang tak yang pasal molybdenum tu? Tak sambung
Molybdenum?
tadi.
Kenapa ya? Molybdenum. Oh, molybdenum dengan pH tu ya? So, for molybdenum, saya tak pasti kenapa dia tinggi. Nanti saya check balik. Okay, kenapa molybdenum's availability increase with the increasing of pH? Saya tak pasti. Sebab apa molybdenum dia diperlukan dalam bentuk okay, saya baru ingat. Yang saya tak tahu pasal boron saja. Sebab apa boron ni dia available for plant nutrient uptake in the form of boric acid. Okay. So ataupun dalam bentuk negatif. Betul kan? Boric acid ataupun dalam bentuk negatif. Saya tak pasti kenapa the availability of boric acid reduce with the increasing of pH. Kalau copper, manganese, zinc dengan ferrum tu kita tahu. Sebab apa? When in alkaline conditions or in high pH, the concentrations of hydroxide ion or OH is very high. So this element, the cation element, copper, manganese, zinc, and ferrums will bind to oxide ion and become dia dihydroxide. Okay, for example, copper dia akan react dengan oxide jadi copper oxide, manganese oxide, zinc oxide, and ferrum oxide. Tapi untuk boron saya tak pasti kenapa dia punya availability menurun in alkaline conditions. Nanti saya check balik ya. Kalau saya dapat nanti saya get back to you the reasons why. From molybdite, okay, so we know that molybdite are available for plant uptake in anion, okay, negative ions. Okay, so kalau dalam negative ion, dia punya proses sama macam positive ion. Okay, kalau in alkaline ions, the hydroxide ion is very high, OH ion is very high. Okay, so the OH ion will replace the binding site of molybdite that initially bind to minerals or organic particles. Okay, so it will release molybdite to soil solutions. Faham tak? Dia sama macam copper, manganese dengan zinc. Kalau dalam keadaan berasid, hydrogen ion concentrations very high. Okay. So apa yang berlaku? The hydrogen ion akan replace the binding site of copper, manganese and zinc and also ferrums dekat CEC. Okay. So bila hydrogen ion bind to CEC, copper ataupun other cation ion will be released into soil solutions. Okay. Itu dalam keadaan acidic. Tapi dalam keadaan basic or alkaline, the OH will replace the binding site of molybdite. Okay, so molybdite will release into soil solutions and become available for plant nutrient uptakes. Okay, faham tak? Faham?
Faham. Terima kasih.
Tak apa, nanti kalau awak tak berapa faham, nanti untuk iron saya dia ada gambar aja, nanti awak lebih senang faham. Okay. Okay, so we continue with our first micronutrients, which is ions, okay, ataupun ferrums or Fe. So what is the functions of iron in plant physiology? Ions are important component in two group of proteins. Okay, we call this kind of protein is metal containing proteins. Okay, what are the proteins that contain ions? Heme proteins. Okay, example of heme protein is heme protein are involved in oxidations, hydrosylations. Okay, example of protein that contains of heme proteins adalah cytochrome C oxidase, catalase, and also peroxidase. Okay, another type of protein that contains iron we call ferrum sulfur proteins. So these kind of proteins involved in oxidations and reductions process. Okay. Example of FES proteins, FES containing protein is NADH dehydrogenase and hydrogenase. Okay. So iron also involved in productions of chlorophylls. Okay. So we know that chlorophyll contain magnesiums and nitrogens. However, they are non-structural components of chlorophylls that also involved in chlorophyll for synthesis. They are sulfur and also ions. Why sulfur and ions also involved in chlorophyll synthesis? Because sulfur usually required by plant to synthesize protein. Same goes to iron. Iron also required by plant to produce a certain kind of proteins, heme protein and FAS protein. So this protein is important component of enzymes involved in chlorophyll synthesis. So reductions or depletions of sulfur or iron in soil will be manifested by chlorosis symptoms. Okay. Sorry ya, saya tak display slide saya. Awak boleh nampak ke?
Nampak je. Nampak tadi kata.
Lagi nampak.
Nampak je. Okay, sekejap ya. Okay, nampak?
Nampak.
Okay. So, the uptake of iron by plant is clearly elucidated by scientists. So we know how plant uptake iron from the soil. So basically, plant can be divided into two groups based on how they absorb protein from soil. Okay, so plant can be classified into strategy 1 plant and also strategy 2 plant. So strategy 1 plant usually contains monocot and dicot or non-gramineous species. And strategy 2 plants usually contains gramineous species of plant. What is gramineous plant? Gramineous plant is pokok-pokok yang macam pokok rumput, contoh bali, Oryza sativa ataupun padi, okay, ataupun apa lagi satu saya tak ingat, oat, okay. So this is gramineous plant. So this kind of plant, they have certain mechanisms to uptake iron from soil. Okay, we go one by one. How strategy 1 plant acquire or absorb ions from soil. Okay, so this is strategy used by non-gramineous plant. Okay, so how they absorb iron from soil? First, ions usually available for plant uptake in ferrous conditions, Fe2 plus. Plant also can take iron in ferric iron, Fe3 plus. Okay, but in soil, ions usually exist in ferric conditions. Okay, in their reduced conditions. Okay, Fe3 plus. When iron exists in ferric ion, Fe3 plus, it tend to bind with CEC or soil particle. Okay, so when this ion ataupun Fe3 plus bind with soil particles or CEC, it cannot be uptake by plant. Plant can be uptake ions in F2 plus. So how plant can convert ferric ion to ferrous ion? Okay, so usually the availability or the conditions of ions in soil influenced by the pH of soil. So if soil condition is very alkaline ataupun dalam kata yang lain dia punya pH sangat tinggi, okay, ferric will tend to bind with particles, with soil particles. Okay, so in these conditions, the non-gramineous plant or strategy 1 plant will pump out a proton from its cytoplasms through to rhizosphere. Okay, so the pump of protons will be conducted by hydrogen ATPase proteins. So hydrogen ATPase protein will pump hydrogen ion from cytoplasms into rhizosphere. Okay, so this will make the concentrations of hydrogen ion in rhizosphere will increase. So the increasing of hydrogen concentrations in rhizosphere will reduce or will induce the acidifications of soil. Okay, so the acidifications of soil will induce the transformations of ferric to ferrous ion. Okay, and then at the same time, the strategy 1 plant will release proteins we call ferric chelate reductase. So saya silap. Okay, the acidifications of soil will release ferric. Kita tahu kan tadi Fe3 plus ni dia bind dengan soil particles. So when the concentrations of hydrogen ion increase in rhizosphere, the hydrogen ion will replace the binding site of ferric dekat soil particles tadi. So as a result, it will the ferric will be released into soil solutions. Okay, so bila hydrogen ion tinggi, hydrogen ion will replace the binding set of ferric dekat soil particles tadi. Okay, and then plant at the same time will release ferric chelate reductase. So this is the enzymes. What the functions of this enzyme? These enzymes will induce reductions process of ferric to ferrous. Okay, And then when iron has been converted from ferric to ferrous, plant can absorb this iron through its special channel. Okay, iron transport proteins. Okay, so the process dia ada tiga proses. Proses pertama, plant will release hydrogen ion. Hydrogen ion releasing in rhizosphere will cause acidifications. Acidifications of soil ataupun higher concentrations of hydrogen ion in soil will replace the binding site of ferric in soil particle. Okay, and then ferric will dissolve in soil solutions. At the same time, plant will release enzymes called ferric chelate reductase. This enzyme will induce reductions of ferric to ferrous ion. Okay, so this process happen in near root tissues. So when ferric has been transformed into ferrous, plant will uptake this ferrous through special protein carrier. Okay, clear, yeah? So this is mechanisms employed or adopted by strategy 1 plant. So the strategy 2 plant will use different mechanisms. So what they did in rhizosphere, the strategy 2 plant or the gramineous plant like padi, wheat ataupun apa ya, uh, ya uh, gandum, padi lah ya. Contoh-contoh lain apa tadi? Saya dah lupa lah. Barley, gandum ataupun padi. Pokok-pokok ni ataupun gramineous plant ni digunakan strategi nombor 2. Okay. So strategy 2 plant is characterized by synthesis of siderophore. Okay. What is siderophore? Siderophore is organic compound that very high affinity toward iron. Okay, they act like a magnet. Okay, they will scavenge, they will attack, they will attract to iron will attract to this organic compound or phytohydrophore. So example of phytohydrophore adalah muginic acid. Okay, so plant will release this muginic acid into rhizosphere through special proteins we call transporter of muginic acid 1. Okay, so TOM1 the functions adalah untuk release phytohydrophore from tissue plant tissue into rhizosphere. So this muginic acids ataupun hydrophore tadi dia ada high affinity toward iron. It will bind with iron and form phytohydrophore ions complex. And plant will have special proteins that can transport this complex from rhizosphere into plant tissues. Okay, so dia punya mechanism lebih senang. Dia ada hasilkan compound yang dipanggil phytohydrophore. So this phytohydrophore like functions like magnet. It will attach to iron. Okay, and then dekat plant tissue juga ada proteins that can transport these ions and phytohydrophore complex from rhizosphere. It will transport this complex from rhizosphere into root tissues. Okay, so sangat mudah, kan? So this is the comparisons between strategy 1 and also strategy 2 plant in terms how they can absorb or uptake ion from soil solutions ataupun rhizosphere. Okay, so saya ulang lagi, strategy 1 plant it will in the first step it will pump out hydrogen ion through ATPase proteins, okay, and cause soil acidifications. The concentrations of hydrogen ion in soil will replace the binding site of ferric dekat soil particles tadi. So the ferric ion will release into soil solutions. At the same time, The strategy 1 plant will produce enzyme called ferric reductase, uh, ferric chelate reductase. Okay, so the functions of these proteins to reduce iron from ferric to ferrous. Okay, and then ferrous ion will be transported into plant root tissues through special protein. Strategi tu one, itu strategi one. Strategi two plant dia lebih mudah. Dia akan hasilkan phytohydrophore. This phytohydrophore will form a complex with iron, and then plant will transport this phytohydrophore ion complex into its tissues through specific proteins. Okay, so mudah saja. The ferric in cytosol is oxidized and transported into xylems. In the phloems and in the symplasms, ferric transported as nicotinamines. Okay, so kalau dalam xylems, ferric, kita tahu ferrous dia dissolve in soil solution, in water. So dia ferrous ion ni dia akan dissolve dalam water, and then it will be transported from lower part of plant to upper part through xylem. In phloem, the movement is from upper part to lower part. So ini biasanya kalau pengangkutan melalui xylem, biasanya the transportations adalah bermula daripada absorptions of ion from soil solutions. But if ions is transported through phloem, it means it being transported from upper part to lower part. Okay, ataupun from one organ to another organ. So this usually happen when plant experience ions deficiency, ataupun it want to transport iron from lower demands organs to higher demands organs. Okay, dalam bentuk nicotinamines. So this is the molecular structure of nicotinamines. Okay, so this is free nicotinamine. Actually, nicotinamines used in higher plants not only for ion transportations, but it can also be used for other metal transportations. Okay, example, nicotinamines also involved in manganese transportations. Apa lagi? Saya lupa. Ada beberapa elements, especially metallic elements that being transported from one part of plant organ to another part through nicotinamines. Okay, so how these nicotinamines can transport ions? If you, this is initial state molecular structure of nicotinamine without metals. It contains 3 carbonyl side chains. Okay, so this one carbonyl COOH. Okay, this is carbon, oxygen, hydrogen, carbonyl group COOH. So this one carbonyl groups, this another one carbonyl group, so this one carbonyl groups. The transformations of ions through xylem is in the form of ferrous. However, the transportations of iron through phloems is in the form of ferric, Fe3+. So this Fe3+ will bind to 3 carbonyl groups. So these carbonyl groups will detach its hydrogens, okay, and then the binding site of hydrogen will be replaced by ferric. Okay, most of ferric is in the vegetative part. For example, grains, in the vegetative part, grains and tubes are often considerably low. It contains low amount of ions. Okay, the symptoms of iron deficiency, apa dia? So we know that ions is structural components of certain proteins, and then these proteins also component in enzymes that involve in synthesis of chlorophyll. So the deficiency of ions will be uh, manifested or exhibited by chlorosis symptoms. Apa itu chlorosis symptoms? Chlorosis adalah when the leaf contains significantly lower amount of chlorophylls. Okay. Dia punya symptoms macam apa ya? Sulfur, magnesium dan juga apa? Nitrogens. Okay, tapi beza dia ions ni dia micronutrients, dia tak mobile, it is not mobile in plant tissue. So the disease symptoms will be observed in upper part, okay, in newly forms leaf, okay, pokok apa, daun-daun yang baru terbentuk. Kalau kita tengok dekat sini, ni adalah contoh pokok strawberry. Okay, sebelah kanan ni adalah pokok strawberry. If you observe, the strawberry contains 4 leaf. Okay, pokok strawberry ni ada 4 je daun. Daun yang kedua yang awal-awal tu kalau nak tengok, yang lower part, dia punya apa, conditions is normal. Tapi yang baru tumbuh ni kita tengok dia sedikit hijau, dia sedikit kuning. Okay. Biasanya kalau daun-daun yang baru terbentuk ni dia akan warna kuning sebab dekat situ proses chlorophyll synthesis masih lagi berlaku. Okay, kalau kita tengok pokok strawberry ni, the new leaf is yellow. Okay, but this leaf as it grow older, dia tak akan berubah jadi warna hijau. Dia akan remain warna kuning macam ni. Sebab apa? Concentrations of chlorophyll tadi sangat rendah. Okay. Ini pula yang sebelah kiri adalah pokok legumes. Okay. So these legumes also suffer from nutrient iron deficiency. Okay. So dia punya symptoms kita tengok apa yang berlaku. Dia punya daun berwarna kuning. Okay. Sebab apa? Chlorophyll synthesis rendah dalam tisu daun yang baru terbentuk ni. There are certain plant that very susceptible to iron deficiency. Salah satu contohnya adalah pokok legumes. Okay. Sebab apa? Legumes ini biasanya pokok legumes kalau berbanding dengan pokok lain, dia punya demands for ions is very high. Okay. Sebab apa? In legumes usually they can establish symbiotic interactions with rhizobiums. So these rhizobiums can fix the atmospheric nitrogens in the legumes in nodules and transform the nitrogens from nitrous gas into ammonia. So the enzymes involved in nitrogen fixations is nitrogenase. Okay, so the activations of nitrogenase, the elements that used to activate nitrogenase adalah ions. Okay, so dalam pokok legumes, ions diperlukan juga to activate the nitrogenase enzyme. Okay, so biasanya pokok legumes ni selain daripada chlorophyll synthesis, the ion juga diperlukan untuk activate nitrogenase tadi itu. Okay, sebab tu keperluan ions dalam pokok legumes lebih tinggi berbanding dengan pokok-pokok yang lain. Okay. Klorin. Boleh kita sambung klorin petang ni? Can we stop here and continue with other topics this evening? Okay tak?
Okay, doktor.
Boleh.
Okey, doktor.
Okay, boleh. So any questions mengenai iron? Okay tak semua?
Okey.
Okay.
Iklima. Mana iklima? Ada tak iklima?
Ada.
So iklima, ada soalan?
Tak ada.
Faham ya?
InsyaAllah faham je setakat ni.
Okay. Insyirah, okay Insyirah? Mana Insyirah? Saya tengok Insyirah ada dalam ni. Any questions from you Insyirah? Tak ada, senyap saja. Zulharis, okay? Tak dengar Zulharis. Okay tak Zulharis?
Okey doktor. No question.
Awak sihat ke?
Sihat je.
Okay. So, dengar suara awak macam kurang sihat je. Siapa lagi saya nak tanya? Syairin, okay Syairin?
Okey doktor.
Okay. Husnah, okay?
Okey doktor.
Okay. So if there is no questions from all of you, I would like to thank for your times and attentions during my class. Kita jumpa lagi petang ni. Okay. So thank you. Assalamualaikum. Selamat tengah hari.
Waalaikumsalam.
Waalaikumsalam. Thank you doktor.